Alright, in this session, we're going to go over all the problems on the Pre-Calculus Honors Semester 1 Review for Final. Okay, we got 40 problems. Let's see how fast we can do them. Okay, now the first part of the test is multiple choice. Not multiple choice, graphing calculator. You cannot do any problem without the calculator. Okay, so 1A, solve. How do you solve any equation on your calculator? Well, you simply make one side 0, like that. Graph this on your calculator and see where the graph crosses the x-axis. If it crosses the axis 3 times, you got 3 answers. Okay? And of course, since we're graphing a trig function, your calculator should be in radian mode. How do you solve any inequality on your calculator? Well, same thing. You make one side 0, like this. Graph this on your calculator right here. And since it's less than 0, then we want to figure out where is the graph below the x-axis. Greater than 0 means where is the graph above the x-axis. So you will have to compute the zeros of the function. This one does not have to be in radian mode because that's not a trig function. Okay, number 2, an open top box with a square base is to have a volume of 2 cubic meters. So you can clearly see that x squared times y equals 2. Find the dimensions of the box so that the amount of material used is a minimum. So what do we want to minimize in this problem? The surface area. So the surface area of this box is x squared, because remember it's open top, there's no top, plus 4xy. But we cannot graph this on our calculator, so we need to get rid of one of these variables. So we use this equation here to solve for y. So y equals 2 over x squared. Take that, plug it in there, and you get x squared plus 4x times 2 over x squared, which of course simplifies to, what is that, 8 over x? Graph that on your calculator with the appropriate window, and you should see this, and then you calculate the minimum, because we want minimum surface area. And again, do not just press the graph button and expect to see something. Set the window. Okay, number 3. In triangle ABC, angle A is 41, B is 77 degrees, and A is 10. Find the area of this triangle. Now, the fastest way to find the area of a triangle, if you know 2 sides and the included angle, is 1/2 AB sine C. So, we need to find a side. So, which side do we want to find? Pick one, and it really doesn't matter. Okay, let's say we want to figure out this side. Then we need to know this angle. Well, all 3 angles of a triangle add up to 180. So, these add up to 118. So, therefore, this is 62 degrees. So to figure out this side here, you use the law of sine, since we know 2 or more angles. So C over sine C is equal to A over sine A. Use this equation to solve for C, and you should be in degree mode. Store that, and then now that you have this stored in C, look, you have 2 sides and the included angle, so therefore the area is equal to 1/2 10 times C times the sine of 77 degrees. So your calculator should be in degree mode for this problem. Number 4. Find the minimum distance between the point 3, 0 and the graph of y equal x squared. So let's draw a picture to see what's going on. Y equals x squared is your everyday parabola. Here is the point 3, 0. What is the shortest distance from 3, 0 to the parabola? Well, I'm not sure what that point is, so I'm going to call it x, y. But of course, y is equal to x squared, so you can substitute that in there. So what we want to do is minimize this distance. That means we need to use the distance formula. So the distance is, between 2 points, is the square root of x minus x squared plus y minus y squared. And since that's only one variable, graph this on your calculator, and with the appropriate window, you should see that. And then you will get a minimum distance. So when you calculate this minimum though, you got to remember the x value stands for the x coordinate of this point. The y-coordinate is actually the distance. So this here is actually the minimum distance. And that's what you're trying to find. So whatever what comes out there, that's the answer. Okay, number 5. In a circle of radius 5, the measurement of the central angle, find the measurement of the central angle if the area of the corresponding segment, and if you remember, this shaded region is a segment, is 1. Now, how do we find the area of that shaded region? Well, it's the area of the sector minus the triangle. So how do you find the area of a sector? 1/2 r squared theta, theta in radians now, minus the area of a triangle, which is 1/2 AB sine C, right? You know, 2 sides and an included angle. And this region needs to be equal to 1. And how do you solve any equation on your calculator? You make one side 0, so what is that? 12.5 theta minus 12.5 sine theta minus 1 equals 0. So on your calculator, you would graph y1 equals 12.5x minus 12.5 sine x minus 1. Graph that, and wherever it crosses the x-axis, that's your answer. And you need to be in radian mode because you're graphing a trig function here. Okay, number 6. A rectangle has 2 of its vertices on the x-axis, and the other 2 is on the upper. Okay, so you got y equal 4 minus x squared, and then there's a rectangle like this. Let's label this point that we don't know, x comma y. So it says, find the maximum area of this rectangle. Well, looking at this picture, what is the area of this rectangle? 2x, right, which is this, times y, which is that. But again, this is 2 variables. We need to get rid of 1 variable. That's why we have this equation. So you take this and plug it in there, and you get 2x times 4 minus x squared. Graph this on your calculator, and then on the appropriate window, you will see a hump, and then you can calculate the maximum. So that will give you the maximum area. Now, of course, your calculator is going to give you the coordinates of this maximum point, but you got to answer the question. They want the maximum area of this rectangle, so therefore, this y-coordinate represents the area, right? So that's going to be your answer. And then, anytime you're writing a best fit curve, whether it's a line, parabola, sine function, log function, exponential function, okay, you go to statistics mode and you fill in the points here. Remember, L1 are the x-coordinates, L2 are the y-coordinates. 1, 2, 3, 5, 8, 13. Holy Fibonacci. So punch this in, select linear regression, and then it says put it in the form y equal mx plus beta, but that's the form they give it to you anyway on your calculator. But again, on the final exam, you need to read the directions, because it might say the best fit straight line can be written in the form y equal mx plus b, find the value of m, or find the value of b. So make sure you put the answer on the answer line. You gotta read the problem. And remember, no questions! All right, and then part 2, no calculator. So here we go. Which of the following are logically equivalent to A or B? Now, first of all, how do you convert an OR statement to a conditional? You negate the first, leave the second one alone. So already we can look for that one. And is that on one of the choices? Not A implies B. Yup, D. But then, remember, when you have a conditional statement, its contrapositive is also logically equivalent. So what's the contrapositive of this? Not B implies A. And is that also one of the choices? You bet your bippy. And are there anything else? Well, look at A. This is choice A, not quantity A and B. How do you distribute a negation sign? Well, distribute, but then you got to change the and to or. Now, is that the same thing as that? Don't be ridiculous. But what about B? You got not A and not B. So if you distribute, you get A or B. That's the same thing. This is called De Morgan's law. So yes, So if you want full credit for this problem, you have to have BDF on the answer line. All right, number 9. What conclusion can be deduced from the following premises? B, not D implies not B. A, if and only if D. Remember, that's the biconditional. You can use it either direction, whichever one is going to be most beneficial. C implies not A. Okay, now since we got B, I think I wrote something wrong. This is not D, fool. Okay, now since I got a B here, if I'm going to use modus ponens, I need B implies something. Where can I get that from? Right there, the contrapositive of this. So B implies D. Then I need D implies something. Where can I get that? From this. So since we can use it either direction, I'm going to use it D implies A because that's going to be useful. And then if I'm going to use the law of syllogism, I need A implies something. And where can I get that? The contrapositive of this. A implies not C. So putting these three statements together, I can conclude B implies not C, but B. Therefore, come on, gorilla implies banana. Gorilla, therefore banana. So right there, basically you're using modus ponens and law of syllogism. Very simple. Okay, number 10. Find the distance between the vertex of the parabola. Okay, now this problem here, if you can answer this problem, you can do 3 problems on the final exam. Okay, so the first step, let's find the vertex of this parabola. What's the fastest way to find the vertex? Negative b over 2a, that's the x-coordinate of the vertex. So negative 30 all over 2 times 3, which is equal to 30 over 6, which is 5. So the x-coordinate of the vertex is 5. How do I get the y-coordinate? You plug it in! Y of 5 is equal to 3 times 20 for 75 minus 150 plus 74. Hey, that's negative 1. Ka-ching! Okay, so find the distance between that point and the line that passes through negative 9, negative 3, negative 3, comma 5. And let's make sure we got that correct. Now, how do we write the equation of a line that passes through 2 points? Well, the first thing you got to do is find the slope. Slope is y minus y minus y over x minus x. So that comes out to 8 over, wait a minute, did I copy this correctly? I just want to make sure. So y minus y over x minus x. Okay, so what do we got? 8 over 6, which is 4/3. Okay, now there's lots of things you can do. Why don't we just let's stay with the basic point slope form. So which point do you want to use? Which one has smaller numbers? This one. So y minus 5 is equal to 4/3 times x plus 3. Okay, now that's the correct answer. However, when you want to use the distance between the point and the line formula, the line has to be in general form. Anyway, on the test, I might ask you, write your answer in general form. So you have to know how to put it in general form. So first thing I would do, get rid of the fractions, multiply both sides by 3. 3y minus 15 is equal to 4x plus 12. So therefore, 4x minus 3y plus 27 equals 0. That's the equation of the line. Okay, now, how do you find the distance between this point and this line? Well, there's a formula, right, that we learned. Absolute value of ax1 plus by1 plus c all over the square root of a squared plus b squared. I'm recording.
Oh, did you find a lunchbox?
Yeah, right there. So, this is A, B, and C. This is x1, y1. Just plug and chug and nobody will get hurt. So what do we got? 4 times 5 minus 3 times negative 1 plus 27 all over the square root of 4 squared plus negative 3 squared. So what is that? 20 plus 3 plus 27, which is 50, all over 5, 10. So you do the problem, you can do 3 problems on the test. Number 11, can I squeeze it in here? Erase, fool. Okay, let's erase. Number 11. This is slow going, man. Find the point on the x-axis. Look, I even give it to you. That is equidistant from these 2 points. Now, what does equidistant mean? It means this distance and that distance are equal. And do we know how to find the distance between 2 points? Yes, you use the distance formula. So what's the distance formula between these 2 points? The square root of x minus x squared plus y minus y squared. And we want that equal to this distance, which is the square root of a minus 7 squared plus 0 plus 2 squared. I think you can solve this equation, but we just can't take any chances. So square both sides. So a squared minus 2a plus 1 plus 16 is equal to a squared minus 14a plus 49 plus 4. A squareds cancel out, and we got, what is that? What is that? What is that? 12a is equal to 17, so subtract 17 from 53. So 53 minus 17 gonna be 36. A equal 3. And make sure you answer the question now. What number are we doing? It says find the point on the x-axis. So the answer would be 3, 0. Is at what point on the x-axis? Number 12. Find the y-intercept of the line that is the perpendicular bisector of the segment whose endpoints are -1, 4, and 5, -6. That will be down here somewhere. Okay, so can we write the equation of the line that's the perpendicular bisector? I hope so. First step, find the midpoint. Use the midpoint formula. Take the average of the x-coordinates, then take the average of the y-coordinates, that's the midpoint. And then you find the slope of this line right here, which is y minus y over x minus x, which is -5/3. Okay? Therefore, what's the slope of the line that's perpendicular to it? 3/5. So, using this point and that slope, here's point slope form. Y plus 1 is equal to 3/5 times x minus 2. And we are asked to find the, I forget already, find the y-intercept. So how do you find the y-intercept of any graph? You set x equal to 0. So if I set x equal to 0 there, you get y equals -6/5 minus 1, which is -11/5. Wow, I don't think I would even make a problem that comes out to an ugly answer like that. Did I do something wrong? Wait, why don't we just check the answers? Hello? What number is this? Number 12. Number 12. Oh, it is in -11/5. Wow, that's ghastly. Obviously, I didn't put much thought in that problem. All right, number 13. Given a linear function such that f of 3 equals to, linear function means line now, and f of 7 is equal to 10, find f inverse of -1. Okay, now remember, this represents the point 3, 2. This represents the point 7, 10. Can I write the equation of a line that goes through those 2 points? Yes, first you find the slope, y minus y over x minus x, which is 8/4, which is 2. And shall we use this one because it's got smaller numbers? Y minus 2 equal 2 times x minus 3. Come on, point slope is automatic already. But since we're using functions, that means you got to solve for y. So y is equal to 2x minus 6 plus 2. So y is equal to 2x minus 4. So it's kind of like f of x is equal to 2x minus 4. So how do you find the inverse of a function? You switch the x's and y's, so x is equal to 2y minus 4, and then you solve for y. So we got x plus 4 equals 2y, y equals x plus 4 all over 2. So this is f inverse. So now we want to compute f inverse of -1, so all you have to do is plug in -1 for x. So if f inverse of -1 is simply -1 plus 4 over 2, which is 3/2. Child's play. All right, number 14. Find, oh come on, this is child's play. Now, to write an equation of a parabola, if you are given the vertex, then you want to use vertex form, right there. Now, since they tell you that, well, not they, I told you that the vertex is 3, 2, then you just go y equal a x minus 3 squared plus 2. And then it passes through the point -1, -4. Now what do you think I'm going to do with that? You plug it in to figure out what a is. So -4 is equal to a times -4 quantity squared 16 plus 2. So 16a is equal to -6. A is equal to -3/8. So therefore the equation of the parabola is y equal -3/8 x minus 3 squared plus 2. That's the equation of the parabola. But then it says find the x-intercepts. How do you find x-intercepts of any graph? You set y equal to 0 and you solve for x. Now what's the fastest way to solve for x? Well, if I were me, this is what I would do. I would go bring this on this side. 3/8 x minus 3 squared is equal to 2. Multiply both sides by 8/3. So x minus 3 quantity squared is equal to 16 over 3. Square root both sides. So x minus 3 is equal to plus or minus 4 over root 3. Add 3 to both sides. X is equal to 3 plus or minus 4 over root 3. Ta-da! But that's just if I'm me. Number 15. Wow, this is really slow going. Find the values of k so that this quadratic function has two distinct real zeros. Now, what tells you what kind of zeros a quadratic function has? The discriminant, which is b squared minus 4ac. And if you want two distinct real zeros, the discriminant must be greater than 0. What if the discriminant is equal to 0? Then you have a double root, a double 0. And what if the discriminant is less than 0? Then you have two complex zeros. Okay, but in this case, we want the discriminant to be greater than 0. Now, this, if you multiply it out, is actually k squared x squared, right? So this is a, this is b, this is c. The discriminant is simply b squared minus 4ac, and we want that greater than 0. Solve this inequality, and that's your answer. So what do I got? 36 minus 4k squared greater than 0. Divide by 4. 9 minus k squared greater than 0. And do we know how to solve inequalities? Yes, you make one side 0, you factor the other side, and then you make a number line. Put the zeros on the number line. No. Think of a number bigger than 3. 4. Plug it in here. 3 plus 4 is positive. 3 minus 4 is negative. Positive times negative is negative. Or you can just think of the graph. If you were to graph this, it's an upside down parabola like that, so it's below, above, below. So minus, plus, minus. See? Minus, plus, minus. Same thing. Now we're looking for greater than 0, so this is the answer. And so on the answer line, you would write that. Or if you want to do this, you can write that. I don't really care. I'll take either. Number 16. Given a quadratic function now, f of 0 equal 4, f of 1 equal 9, f of negative 2 is equal to 6, compute f of 2. Well, if you are given 3 points on a parabola and you don't know if one of them is the vertex, then what form should you use? This one, ax squared plus bx plus c. So what do you think I'm going to do with these 3 points? Plug it in. If you plug in 0 for x, you should get 4. So plug in 0 for x. 0 plus c equal 4. Oh, I just figured out c is 4. Okay, if I plug in 1 for x, a plus b plus c, you should get 9. And if I plug in negative 2 for x, what is that? 4a minus 2b plus c equals 6. But we already know c is 4, so this is 4, this is 4. So that's just like saying a plus b is 5, and 4a minus 2b is equal to 2. But I can divide by 2, so 2a minus b equal 1. So if you simply take those two equations, add them, and you get 3a equals 6. Therefore, a equal 2. Plug it back into this one. B equals 3, and we already know c equals 4. So therefore, the quadratic function we're looking for is 2x squared plus 3x plus 4. And then make sure you answer the question, which is compute f of 2. I think you guys can plug in 2, yeah? In fact, I know you can. Oh my goodness, I'm laboring already. Oh my God. Okay, where are we? binomial theorem. Find the fourth term of the binomial expansion, a plus b to the 10th power. Well, you know every term is going to be of the form 10 choose something, a to the something, b to the something. Now, if we want the fourth term, let me make sure we're doing it right. Yeah, fourth term. Then this is going to be 10 choose 3. Because remember, the first one is 10 choose 0, right? Yeah. And whatever number you put here, that goes there, and then the 2 powers have to add up to 10, so that's 7. And do we remember how to compute 10 choose 3? Yeah. 10, 9, 8 over 3, 2, 1. Let the canceling begin. Dooga dooga 3, dooga dooga 4. That's 120. Okay, and then b, we got fraction, 1 plus x to the 1/2. Now the fourth term, you know what? I think we should go through the binomial theorem because some of you just forgot it, okay? So what happens when the power is not a whole number? Then you got to use the general binomial theorem. So a plus b to the n, a to the n plus n. Then the power of a goes down by 1, the power of b goes up by 1. And then n minus 1 all over 2 factorial. The power of a goes down by 1, the power of b goes up by 1. Notice the 2 powers always add up to 1/2. And then the next one, n minus 1, n minus 2 all over 3 factorial. The power of n goes down by 1, the power of b goes up by 1. That's the binomial theorem. So this is the fourth term right here. All you have to do is simplify it. And I'm going to let you do that because I think you can multiply and divide numbers, but who knows? Number 18, solving inequality. Yippee! Now, does this fit one of the forms that we learned? That's a 7, fool. Does this fit one of the forms we learned? Yes. So, absolute value of gorilla is less than banana, so you put gorilla in the middle, and then put negative banana and banana there. Come on! A monkey can do this. Add 1 across the board. Divide by 2 across the board. Come on! That's child's play. Okay, we're going to need more room for the next one. Alrighty then, B. Absolute value of x plus 1 is greater than 3x minus 2. Now, does this fit one of the forms? Yes, this one. Right? And what does this mean? X is less than negative a, or x is greater than a, right? So this is like the x, and that's the a. So x is less than negative a, or x is greater than a. Solve each one. So this is like 4x is less than 1. X is less than 1, 4. And then negative 2x is greater than negative 3, so x is less than 3/2. And then or. What does or mean? It means union. So if you have a difficult time, make a number line. Here's 1, 4. How do you graph x is less than 1, 4? How do you graph x is less than 3/2? What's the union of these two? Well, if you put all of these numbers in a box and put all of these numbers in a box, what's in the box? X is less than 3/2. That's union. As opposed to if it were and, then you take the intersection, which would be where it overlaps, and then in that case it would be x is less than 1, 4. So yes, you need to know the difference between or and and. And then C, how do you solve an inequality like this? Multiply both sides by x minus 3. Don't be ridiculous, because we don't know whether that's positive or negative. Now, if you wanted to be clever, you could multiply both sides by x minus 3 quantity squared, which we know is positive. But let's just go with the standard. The standard way of solving inequalities is you make one side 0, and then you factor the side and make a number line. So in order to factor the side, you need to make a least common denominator. So that's going to be minus 2 times x minus 3. So your algebra needs to be solid. So what is that? x plus 1 minus 2x plus 6 all over x minus 3 is greater than or equal to 0. So that's like negative x plus 7 all over x minus 3 is greater than or equal to 0. But I don't like the negative in the front, so I'm going to multiply both sides by negative 1. So x minus 7 over x minus 3 is less than or equal to 0. Bust out the number line, 3 and 7. Yes, that's included, but that's not because it makes the bottom 0. And then how do I know it's plus minus plus? Just plug in numbers if you don't know. And we're looking for less than or equal to 0. So your final answer is going to be 3 to 7, including 7, but not 3. You have to be good at that in calculus, man. In fact, you got to be good at all of this when you take calculus next year. There's no hiding. Number 19, write a polynomial function with integral coefficient, leading coefficient 1, so that its zeros are 2 plus I and negative 4. Now, what did we learn? If 2 plus I is a root, 2 minus I got to be a root. Well, we're writing a function, so it's actually zeros, okay, if you want to be exact. Okay? Now, I'm not going to do this the long way. Go x minus this, x minus that, and multiply it out like a mad dog. I'm not going to do that. I'm going to learn what I taught you guys, like this. You know it's going to be a cubic, and then we're going to make the leading coefficient 1 to make it easier. So remember this thing? Do you remember this? Well, it's not going to be equal to 0 actually. It's actually equal to f of x, function. So it's actually equal to y. Because we're doing a function, but it's the same thing. But not really. But okay, anyway, remember, negative b over a is the sum of the roots. C over a is the sum of the roots multiplied 2 at a time. Negative d over a is the sum of the roots multiplied 3 at a time. So just remember, 1 at a time, 2 at a time, 3 at a time. So what are the sum of these 3 roots? What's this plus this plus this? 0. Because we made a1, so it makes this problem a lot simpler. Now you multiply the roots 2 at a time. Multiply these two. Negative 8 minus 4i. Multiply these two. Negative 8 plus 4i. And then multiply these two, which is 5. Well, remember I squared is negative 1. And then, ooh, these cancel out, so you get negative 11. And finally, 3 at a time. So now remembering, when I multiply these two, you get 5. So 5 times negative 4 is negative 20. So I guess your final answer would be x cubed minus 11x plus 20. But make sure you read the directions on the test, because it might say something like this. The final answer can be written in the form ax cubed plus bx squared plus cx plus d. What is the value of a plus b plus c plus d? And therefore, what would it be? Because this is 1. Then the answer would be 10. So read the directions. Okay, second page. Oh my goodness, I'm just going to make sure the camera is still going, because it would be a bummer if it stopped. Yes, it's still going. 33 minutes. Let's see if we can finish this in an hour. Not likely. I'm tiring, I tell you that right now. Number 20. A right circular cylinder is inscribed in a right circular cone. So it's kind of looks like, maybe if I gave you the picture, it would be a lot simpler. Okay? So radii 4 and 12. What if I gave you this picture? Would it be easier to do the problem? X represents the radius of the cylinder. So this is X, I guess that's X as well. Okay? Write the volume of a cylinder as a function of X. Now you guys already know, when you see something like this, you gotta be thinking similar triangles. Okay? So first of all, you gotta know your volume formulas, right? The volume of a cylinder is equal to pi r squared h, right? So pi, the radius is X. Now the problem is, we don't know what the height is right there. Or I guess you want to call that the height. And that's where similar triangles comes in. So you got 3 similar triangles here. You got the Papa Bear, you got the Mama Bear here, and then you got the Baby Bear up there. Now if you're going to look at the Mama Bear, then you need to call this one 4 minus x, right? Because if that's x and the whole thing is 4, that's 4 minus x. And if you're looking at like the Baby Bear, then this would be 12 minus h, right? Right? Because the whole thing is 12 and that's h. So which 2 do you want to do? It really doesn't matter. Use any 2 out of the 3. Like I'm going to use the Papa Bear because in the Papa Bear you just got 12 and 4. So 12 over 4, right? Long leg over short leg. And if you're smart, if you have foresight, I'm going to use the Mama Bear. Long leg over short leg. H over 4 minus x. And of course this simplifies to 3. So h is equal to 3 times 4 minus x. And then you can take, that's the height. So then they put that here, 12 minus 3x. Or if you put it factor form, whatever. I don't care what form. Okay, now part B. For what values of x is the volume equal to 24 pi? So what you do is you set the volume equal to 24 pi. Solve this equation. Do we remember how to solve equations? Well, I hope so. Can divide both sides by pi. Multiply out, so 24 is equal to 12x squared minus 3x cubed. Hey, I can divide by 3. 8 equals 4x squared minus x cubed. How do we solve cubic equations? Make one side 0. X cubed minus 4x squared plus 8 equals 0. And how do I factor cubics? If you don't see a factor by grouping thing right away, synthetic division. So you write down the coefficients, factors of 8 over factors of 1. So plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. So if this equation has a rational root, it has to come from that list. So you can clearly see that 1 doesn't work. So if I'm nice, I'd probably make 2 work then, yeah? Let's just see. 1, 2, negative 2, negative 4, negative 4, negative 8, 0. Yeah, and if the remainder comes out 0, that means x minus the number in the box is a factor. And the other factor comes from this, x squared minus 2x minus 4. And so what are your 3 answers? X equals 2, and then this one doesn't factor anymore, so we got to use quadratic formula. And I'm just going to do that in my head. That looks like a 1 plus or minus root 5. Box that, that's the answer. Write that on the answer line. No moose breath, because you can clearly see from this picture that x has to be between 0 and 4, right? Because otherwise, look, doesn't even make sense. That's the domain of the problem. So any answer that's not between 0 and negative and 4, you got to cross out. So you got to erase that one, brother, sister, whatever. All right, that was fun. I like that problem. Some of you are thinking, I think I'm skipping that one. Go ahead, make my day. Okay, 21. F of x is equal to the square root of x cubed plus 2x squared minus 5x minus 6. Now, how do you find the domain of a square root function? The inside has to be greater than or equal to 0. And how do we solve inequalities? You make one side 0 and you factor the other side. So in order to factor this, we need to do synthetic division. Factors of 6 over factors of 1. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. 1 doesn't work, hopefully 2 does. Let's try 2. 1, 2, 4, 8, 3, 6. Bingo! So x minus 2, x minus the number in the box, and then you look at these depressed coefficients. And then that factors some more. Woo-wee! And then you make your number line. Negative 3, negative 1, 2, and what are we looking for? Greater than or equal to 0, bozo? So yes, all of these are part of the solution. And how do I know it's plus, minus, like that? Well, if you don't know, then just plug in numbers. But come on, odd powers. Plus, when you plug in a number bigger than 2, like 3, positive, positive, positive. It's a positive. Okay, we're looking for greater than, so your answer will be negative 3, negative 1, union 2 to infinity. All right, 22. Ooh, I see a difference quotient. F of x is equal to x cubed. Part A, compute the difference quotient. And remember I told you all of calculus is based on this expression right there. Okay, so you got to learn how to form the difference quotient. Break it up into parts, this. That means substitute x plus h in for x in the original function. So that's going to be x plus h cubed. Then you subtract the original function, and then you divide the whole critter by h. And then, of course, You need to simplify. So how do I simplify this? Well, if you multiply this out, you're going to have x cubed plus 3x squared h plus 3xh squared plus h cubed, right? Minus x cubed all over h. These cancel out. Can I factor out an h on the top? You bet your bippy I can. And then these cancel out. Final answer, survey says, I'm missing something. That's an h there. I knew I was missing something. Okay, so 3x squared plus 3xh plus h squared. Easy. Is this function odd or even? Well, how do you determine if a function is odd or even? You plug in negative x for x. Simplify it. Is that the same as the original function? No, if it was the same, it would be even. Is it the opposite? Yes, so therefore it's odd. Very simple. And then is f 1 to 1? Now, what does a 1-to-1 function do? That means it has to pass both the vertical and the horizontal line test. Now, this is a base graph that we should know, y equal x cubed, right? Does that pass both the vertical and the horizontal line test? Yes, so it's 1-to-1. Okay, number 23, 23. Here's a piecewise function. It says completed. Wow, that's easy. Okay, now remember, whenever you see an absolute value, you make a piecewise function, right? So what makes the inside of that 0? 2. So x is greater than 2, x is less than 2. Now normally, one of them would have an or equal to, however, in this case, it makes the denominator 0, so no, because you can't have undefined. Now remember how absolute value works. If the inside is positive, you leave it alone. If the inside is negative, you negate it. Now if x is greater than 2, think of a number greater than 2, like 3. Then isn't that going to be positive? So you leave it alone. See, this thing here, it's either you leave it alone or you negate it. That's how absolute value works. Now, think of a number smaller than 2. The inside is going to be negative, right? Like 1 minus 2. So you negate it. So you're going to end up with x squared minus 4 all over negative x minus 2. That's how you make a piecewise function. And then, of course, you simplify. Because this can be x plus 2 factored, right? These cancel out. And so all you're left with is x plus 2. And then same thing with this. Factor, cancel, and you get negative x minus 2. And there you go. That's your piecewise function. And do we have to graph? No! Okay, well, you know what? I'm just going to graph it because I think you guys should. Who knows what I'm going to ask on this test? Okay, now here. 2. Plug in a number, plug in 2 into this, you get 4. And it's not included. And this is a line with a slope of 1. Ta-da! Plug into that piece, you get negative 4. And the slope of that line is negative 1. So it looks like that. There you go. That's what that piecewise function looks like. And remember, all graphs are to be drawn on the back of your answer sheet. Okay, 24. Gosh, this is slow going. Okay, now you got to know what will affect the graph. Write the equation of the graph obtained when A. This graph is reflected about the x-axis. How do you make a graph reflect over the x-axis? You simply multiply it by negative 1. So all you have to do is just multiply it by negative 1 like that. That reflects it over the x-axis. B, reflect it over the y-axis. What reflects the graph over the y? You know what? Why don't I write it down? This, so the first one is this. That reflects it over the x. This reflects it over the y. So that means substitute negative x for x. So like this. There you go. That reflects it over the y. Part C, reflect it about the line y equal x. So to make a graph reflect over the line y equal x, that means we have to find the inverse. So thinking of this as y, how do you find the inverse? You switch the x's and the y's, and then you solve for y. So 3y equal x minus 2, y equal x minus 2 over 3. Easy money. Okay, D, the x coordinates of f of x are multiplied by 2. So what is that? F of the x coordinates are multiplied by 2. Is that a 2x or x over 2? Why am I even asking you? Nobody's even there. Okay? And the y coordinates are multiplied by 4. So, woo! So that's what you want. So you take your original function, which is right here. So what does this do? This means you substitute x over 2 for x. Like this. Substitute x over 2 for x. And then you multiply the whole darn thing by 4. I think you guys can handle that. You guys can simplify that. Okay, E. This graph is translated 2 units up and 4 units left. Now, how do you make a graph go 4 units to the left? And then 2 units up? Okay, so applying it to this function, you're going to get y equals, so this means substitute x plus 4 for x, like that. And then add 2 to the whole thing. And then I will leave the simplifying to you. Okay, what the 20, oh, we got a whole bunch of graphs here. Okay, y equal x. I'm gonna factor this puppy already. Okay, so when you graph rational functions, go through the 4 steps I taught you. X-intercept. Look at the top. When is the top 0? Y-intercept. Plug in 0 for x. Vertical asymptote. What makes the denominator 0? Horizontal asymptote. Well, if the degree of the top is bigger than the bottom, then no more horizontal. But if the degree of the top is bigger by 1, then you have a slant. So to get a slant asymptote, you got to actually divide. Now, I am going to do synthetic division. Now, if you multiply this out, you're going to get x squared minus 2x plus 1. So that's going to be 1, negative 2, 1. And when you divide by x plus 1, then you just put negative 1 in the box. So you're going to get 1, negative 3, 3, 4. So when you divide this by this, you're going to get x minus 3 plus negative 1 over the divisor. And as x approaches infinity or negative infinity, this part here goes to 0. So that's why y equal x minus 3 is your slant asymptote. Basically, that part right there. So, so the graph is either up there or down here. It's got to be down there because otherwise it would cross the x-axis. And then since it's exploding down on this side, it's got to explode up on this side. And then, whoo, and then it bounces off and it goes like that. How come it bounced off? Even power. How come if it explodes down on this side, it explodes up on the other side? Odd power. Odd power in the denominator. Okay, next one. Hey, that looks just like the reciprocal of this one. Hey, what's going on, man? Okay, so go through the 4 steps. X-intercept. What makes the top 0? Y-intercept. Plug in 0 for x. Vertical asymptote. Horizontal. If the degree of the bottom is bigger than the top, then it's y equals 0. Does that bother you that that point lies on the horizontal asymptote? That's right, it shouldn't. Because horizontal asymptotes only take effect out here. Ah! So, we got this point. We know the graph's going to be here, and then is it going to bounce off or go through? It's going to go through because that's an odd power. This x-intercept came from that factor, odd power. And then, on the opposite, since it explodes up on this side, it's got to explode up on the other side because this vertical asymptote came from here, even power. Even power on the denominator means it goes the same direction. And then, what do I do? So as the graph goes out to the left and the right, the graph got to get closer to whatever your horizontal asymptote is. Quite simple. Okay, C. Okay, do we know our base graphs? Probably not. So your base graph is arc sine x. Let me draw the base graph.